Hi, thanks for tuning in to One India. So, if you've been hearing about cyclones more often in the news nowadays, that's because they have indeed increased in frequency. So, what's the reason behind this? What's causing it? What are the implications of it? And can we prevent or can we delay such erratic weather phenomenon as far as India is concerned? So, to understand all of that, we are being joined by a renowned Earth system scientist at the University of Maryland, Professor Raghu Murtugudde. Thank you very much, sir, for sparing your time.
Thank you, Deepali.
So let me dive right in and ask you the main question, which is, are cyclones increasing in frequency and what's the reason behind it? India's recently been battered by two pretty intense cyclones, both on the west and east coast. So why is this happening?
Yes, so I think the Indian Ocean is best discussed in terms of the season. So there is a pre-monsoon season of cyclones and there's a post-monsoon season of cyclones, which is very unique to the Indian Ocean. The typhoons and the hurricanes have more fixed seasons. Because of the monsoon circulation, our cyclone season gets split into two. So Bay of Bengal has typically been the king of cyclones, and post-monsoon season has been the most intense season of cyclones.
This meeting is being recorded.
What is unusual is that the pre-monsoon season is now seeing more regular cyclones, both in the Arabian Sea and the Bay of Bengal. And we can talk about the post-monsoon season later. But since about 2016, we have been seeing every year cyclones in the Arabian Sea and the Bay of Bengal, and they are placed very close together. All this is, of course, trends. So when we say trends, we just don't look for the number of cyclones. We want to see their tracks, how fast they're intensifying, and how close they are forming, like Taukte and Yas formed almost within the same one ended and the other one immediately started. So the trend itself has to be defined properly.
Right. So is the Indian Ocean more prone to cyclone formation? Are the conditions here more favorable to cyclone formation? Is that why we see so many cyclones around this area in Asia specifically?
Yeah, Indian Ocean has several key ingredients that were already favorable for cyclones. It's a warm ocean. Compared to other tropical oceans, we are really much warmer all year long. This is, of course, good for the monsoon circulation and the moisture we need. But warm ocean also means a lot of convection, which provides the seed from which the cyclones grow, like the rotation you need, called vorticity, from which cyclones can grow by taking the energy from the ocean, is always available. And the other ingredients like the vertical motion, which lifts the moisture from the surface to feed the cyclones. So Indian Ocean has had favorable conditions. In this situation, it is also warming rather rapidly and monotonically because of its very specific configuration, which is making it even more prone to the trends, increases in the cyclones, their intensification, and there are changes in the tracks because of what's happening to the west of us over the Middle East and the loading of the dust over the Arabian Sea and so on.
Right. So I've also been reading that the Arabian Sea has had more frequency in the number of such cyclonic disturbances, which wasn't a regular feature before. It's supposed to be a tranquil water body as compared to the Bay of Bengal. So what's the reason behind this?
It had typically fewer cyclones. So if you look at 1980 to 2000, it had both pre and post monsoon cyclones, only about one every other year, and maybe once in a while it would have two in the post monsoon season, because the monsoonal circulation is so strong that the winds change from the surface to the upper atmosphere so strongly that it chops off the energy from the cyclones and it doesn't let it grow. And that's the reason why Arabian Sea is also much colder. That's why it was not so prone. But because it was colder and because the monsoonal circulation is changing, it is warming much faster as well. This is why it has become now so much more active in pre-monsoon cyclones, but it has become much more active in the post-monsoon season. For example, Arabian Sea is saying almost double the number of cyclones now compared to the 1980 to 2000 period.
So these changes you're talking about, sir, are these natural changes or are these man-made changes?
They are definitely contributed because of the contribution is mostly coming from human activities. It's kind of complicated in terms of where the changes are happening and how the heat is being brought into the Indian Ocean and why it's warming more in the Arabian Sea side than than the Bay of Bengal. Sorry, so it has a huge contribution from human activities and greenhouse gas increases and deforestation and other things.
So should we, sir, start expecting more such frequency in cyclones, or should we start expecting more intensity in the cyclones that we see in the future, and how should we start preparing for it?
Yeah, so it's a good question. It's a bit complicated in the sense that we tend to focus on the Indian Ocean, but actually cyclones are a global phenomenon, as you know. And the total number of cyclones over the whole world haven't shown necessarily an increase. But what is happening is the more intense ones are becoming more frequent. And Indian Ocean is consistent with that global trend. So the total number of cyclones over the Arabian Sea has jumped. It may not jump much more, but everyone that's going to form is likely to intensify very rapidly. So Taukte intensified in just 2 days as opposed to other cyclones from last year or earlier, which were taking 4 or 5 days. So this is a worrisome trend that we have to look out for.
Right. Our predictive mechanisms, our prediction systems have improved over the years. So are they still going to be able to, I've been reading that if as the oceans become warmer, these cyclones and other such erratic weather phenomenon become more unpredictable. But are our systems sound enough to be able to predict them, predict their intensity? Do they increase so suddenly that we'll miss out on how intense they can actually get? Will be able to predict their paths?
A very good series of questions. So there are several aspects to it. How quickly can you say that a cyclone is forming? And then can you say reliably how quickly it will intensify? And of course, then where it will go. So those three aspects, as you saw now, IMD is saying more than a week before that a cyclone is forming. Both Taukte and Yash were predicted. The formation itself was predicted more than a week before. So in that sense, the cyclogenesis is what it is called. It's as if somebody is throwing a seed and you are saying, okay, that one will grow. So that's a very key improvement in forecasting, because that allows you to prepare the actual cyclone forecasting very well. And IMD has done very well also in terms of the rapid intensification. It's not perfect yet, because the observations that you need from the ocean, from the atmosphere, where the moisture is going to feed the cyclone to grow very rapidly, and so on, have to be built in terms of satellite data, drones, maybe ocean observations, land observations, and so on. They are all there, and the track forecast has become quite precise as well. But as you saw in Yash, at the last moment, the landfall was slightly modified. So obviously, we can always get better and better. And the expectations are also going up from the people in terms of, for example, if you have to evacuate 10 lakh people, you cannot do it in 2 places very quickly. So you need some reliability several days ahead, or at least as far ahead as possible. So those are getting better, and we have some ways to go. And the other aspect is how the systems are responding, whether it's the national disaster recovery or local governments and local disaster management. So all those have to be combined.
Okay. So India has a vast coastline. It's over 7,000 kilometers. So can a cyclone or such, typhoons or cyclones, can they be expected anywhere along the coastline, or are there specific places where they make landfall?
Historically, we have seen that Odisha seems to be a bullseye, and obviously all the way from Tamil Nadu, Andhra has got several hits. Of course, Bangladesh, West Bengal got some, Burma has got some big one. So Bay of Bengal is very active. In the Arabian Sea, typically we have seen them being steered towards Oman, northwest. That's the direction for most hurricanes and cyclones and typhoons. Because the winds carry them towards the northwest, and in the big oceans like the Atlantic and Pacific, they will go north and then they curve towards the east. Whereas we have very little space in Bay of Bengal and Arabian Sea. So the recent tracking of the cyclones up the coast into Gujarat or Alibag and so on, this is something that has to be watched because, as I said, we don't know yet whether the warming over the Middle East and the dust storms, like this year, there were big dust storms in Saudi Arabia, which loaded the dust on the northwestern Arabian Sea. That could have steered these cyclones more up the coast. So the possibilities all around the rim countries of both Arabian Sea and Bay of Bengal. The key is to see if that is going to systematically change or they will continue to follow the historical tracks.
Right. So my perhaps my last question to you would be, sir, that you have said that a lot of man-made factors also contribute to these weather phenomena. Global warming, of course, is a major key factor. Global warming, as the name suggests, it's a global phenomenon. So what can India do to protect its vast coastline? Can it do anything regionally to stall these disturbances?
I wouldn't think of it as efforts to stall them. It's always about predicting them much better, as reliably as possible, taking care of the disaster recovery management and risk reductions. So there is a whole lot of processes starting from the predictions, which includes the observing system that has to be improved to improve the forecast themselves. So India has made tremendous investments in weather, climate, and hurricane cyclone forecasting, which is yielding results. And the last mile problems of communicating the risks and getting people to act is getting better. So Odisha is ahead of it, everybody, because they have had experience. Kerala is doing very well in terms of responding to floods, extreme events, and so on. So they have yet to face cyclones. How well will Mumbai do? How will Gujarat do? I think they have done very well in terms of reducing at least number of deaths and so on. So this will be the key. But in terms of recovering natural defenses, of course, on land also we need to do afforestation, reducing deforestation, building codes, flying projectiles, kacha houses and slums that become very vulnerable when the storm comes in, floods come in, sea level is rising. So INCOIS is doing incredibly good waves and storm surge predictions, which can be used to prepare for plans. And of course, there are mangroves and coral reefs, which have seen some human impacts and losses, which have to be recovered, protected. There is some evidence that India is recovering mangroves, but we have a long way to go. And this ocean warming is also hurting the coral reefs, which we have to protect. So there are multiple components to it. And if you want to go down to reducing vulnerability of the people, there is some indication that even poor women who, if they have education of up to 4th, 5th, 6th, 7th grade, they do much better in dealing with warnings and protecting their family. And vulnerability goes down a lot to these natural hydroclimatic hazards. So that has to be taken care of as well in terms of where the vulnerabilities can be reduced.
Right, sir. And finally, what are your comments on the Paris Climate Agreement? That's something so many nations have agreed on to keep the temperature targets below 1.5 degrees. Do you think many experts say that this will not be enough? What are your thoughts?
Yeah, so the 2 degree C temperature target was actually not scientifically determined. It was picked by Bill Nordhaus, who is an economist who won the Nobel Prize a couple of years ago for his climate economics work. And 1.5 came along saying 2 degree C is too dangerous, so we need to reduce it. So the danger I see is these are good targets, and Paris Agreement is a way to go towards that, but none of the commitments will get us to 1.5. In the way we are emitting carbon dioxide and other greenhouse gases right now. So we have to keep that in mind, because just today or yesterday, there was a paper out saying that we are going to hit 1.5 degrees C in 5 years. The problem is already so many changes are happening. We are discussing cyclones. There is a glacier breaking off of Antarctica, Greenland is melting and so on. Nothing more dramatic will happen when we hit 1.5 degrees C. And it is possible that a big El Nino will come and we will cross 1.5 and next year we may come down again. So we have to be careful about hyping up these specific targets, because it's not clear to people 1.5 degrees C is dangerous, but how long? Is it dangerous if it lasts for 10 years, 100 years? What happens if it just crosses for 1 year? Because as soon as it crosses, everybody is going to scream saying, oh, we crossed. People will look around and say, wait, nothing happened. So we need to be aware. But such targets are important to get agreements like Paris Agreement. But monitoring, reporting, and verification are going to be very critical. So we already know that the commitments that were made have to be revised already, because we are not going to meet any of the reasonable targets with the agreements that we have already committed to. It's a democratic process of committing voluntarily, which is great, but how do we get countries to go beyond and do more? This has to involve funding for countries to do more, and technology transfers and so on.
So I just want to throw in one last question there. Since we were talking about glacier burst, glacier breaking off Antarctica, it reminded me of the glacier burst in Chamoli in Uttarakhand in India. What could be, it was never really settled on, the cause was never really discussed and really pinpointed. So what could the cause have been? Recently in the news, there's a speculation that there's crack on that glacier once again. So it could again trigger some sort of devastation. So what are the reasons behind this happening?
So if you look at Himalayan glaciers, the ones at the top, they are on a very steep slope and they are clean. So they may be having similar processes as what we see in Greenland glaciers, for example, where the top of the glacier can melt, and that melt water then reflects much less sunlight. So more and more energy gets absorbed, and that water begins to bore into the glacier and creates what are called moulins. They're almost like waterfalls going down to the bottom, and they can create a lubrication at the bottom and make the glacier slide. So that has to be looked at for Chamoli. It's not yet clear. But the other complication is many of the glaciers in Himalaya are also so-called debris-covered glaciers. They are very dirty. They have huge amount of small rocks, big rocks, dust, and so on them. And emissions are also being deposited on top now. And that also reduces the reflectivity and increases the absorption of sunlight and energy and creates melt. So it's not so easy to track the moulins or the boring of the fresh water from the top in Himalayan glaciers. But the slope is one of the great factors. And we have had some earthquakes. We don't know how many of them got loosened because of that. So it's a complicated factor. And of course, India has established a high altitude observation system, observatory in Himalayas. Still a lot of restrictions on collecting data in terms of using drones, for example, putting GPSs. We could easily be putting GPSs and using drones and monitoring them and warning people that this is becoming more vulnerable for a burst. So we need to get ready for that, because in parts of the Himalayas, there is amplification of the warming. So some parts of central Himalaya are warming faster than the global warming. Right. And we need to understand why it's happening and what the consequences are, because of course it's possible that a warmer air will also take more humidity and create more snowfall. So for example, Karakoram glacier is doing well because it's getting more snow because of such processes, whereas some others are melting faster. So because of this long Himalayan range and the complicated local processes of which one is being affected by the Pacific, which one is being affected by the Indian Ocean, which one is being affected by Western disturbances and Mediterranean, the dynamics are different and complicated, but we need to monitor them very carefully.
And for that, new technology is the way to go.
It is, and scientists are ready to do it, but there are obviously security concerns and so on. So obviously we have to work with the defense and governments and so on. But it's a danger that affects all countries around. So some international cooperation is definitely needed.
Right. Professor Murtugudde, thanks very much for demystifying cyclones and climate for us. Thanks very much for sparing your time.
Thank you, Deepavali.